One decision saved 3 months of development, but cost the company nearly 5 crore rupees. Imagine this. After 2 years of laboratory development, your chemistry works perfectly. Management wants to launch quickly. To save time, the pilot plant is skipped. The first commercial batch starts. 4 hours later, foaming begins. Yield drops. Filtration takes twice as long. A new impurity appears. The batch fails. Could a pilot plant have prevented this? If the chemistry already works, why spend another 3 or 4 months in a pilot plant? Isn't that just delaying commercialization? Actually, no. The pilot plant is where chemistry meets engineering. Think of product development like launching a new aircraft. Engineers first design it, then they build a prototype. Then they test it. Only after successful testing do passengers board. Nobody skips prototype testing. In chemical manufacturing, the laboratory proves chemistry. The pilot plant proves engineering. Commercial manufacturing proves business. Before commercial manufacturing begins, engineers need answers. Will the reactor mix properly? Can the cooling system remove heat? Is the heating profile acceptable? Will filtration become a bottleneck? How long will drying actually take? Can operators safely perform every step? The pilot plant answers these questions before production starts. In the laboratory, a magnetic stirrer mixes the entire reaction quickly. In a 5,000-liter reactor, mixing becomes much more complex. Some regions mix well, others become dead zones. Catalyst concentration becomes uneven. Side reactions may begin. Pilot plant trials help engineers optimize impeller type, agitation speed, and baffle design. Now consider an exothermic reaction. In the laboratory, maintaining 70 degrees is easy. In a commercial reactor, heat removal becomes slower. Temperature rises to 82 degrees. Side reactions increase. During pilot trials, engineers redesign the addition strategy and confirm that the cooling system can safely remove the reaction heat. Crystal size is strongly influenced by cooling. Rapid and controlled cooling in the laboratory often produces large crystals. At commercial scale, slower cooling changes crystal growth. Fine crystals form. Filtration slows. Drying becomes longer. Pilot plant studies help optimize cooling profiles before full-scale manufacturing. Filtration is one of the most common surprises during scale-up. A slurry that filters in 15 minutes in the laboratory may require 4 hours in an industrial ANFD. The reasons include thicker filter cakes, different particle size distribution, and higher resistance to flow. Pilot plant trials reveal these bottlenecks before production. Drying also changes dramatically with scale. Laboratory samples dry in thin layers, industrial dryers handle much larger quantities. Heat transfer slows. Drying time increases significantly. Pilot trials help estimate realistic production cycle times. Many companies believe pilot plants increase project cost. In reality, they reduce project risk. They prevent expensive failures, improve process understanding, build operator confidence, and increase the probability of first batch success. Every process contains unknowns. The question isn't whether problems exist. The real question is, where do you want to discover them? In a 500-liter pilot reactor, or in a commercial batch worth several crores? Pause the video and tell me your answer in the comments. I'll discuss the correct answer and explain why at the beginning of the next episode. In this episode, we learned why pilot plants are essential. In the next episode, we'll focus on one of the biggest scale-up challenges, mixing. Why does a reaction that mixes perfectly in a laboratory behave completely differently in a commercial reactor? We'll answer that using real industrial examples. Thank you for watching PharmaChemE. If you found this episode useful, please like, subscribe, and share it with your colleagues. Remember, chemistry creates the molecule, but engineering makes it manufacturable. I'm Ankush Chopra, and I'll see you in the next episode.